Hello, everyone, and welcome back. I'm here with Gavin Wood, who's going to talk about Substrate and what it is and where it's going. So I'll let you take it from here, Gavin.
Thanks, Carl. Hello, welcome to the, I don't know, is this the third, fourth online conference for Substrate, Sub0. Unfortunate that we can't all be in the same room chatting and sharing beers, but there it is. COVID is what it is. I've been sort of tapped to do the keynote for this. I'm not gonna take up too much of your time, but I figured for the keynote it would be quite nice to talk a little bit about Substrate's history and what it is that we've been working on and what it is that we're continuing to work on. So, without further ado, for those who don't know, Substrate began as Polkadot, back in late 2017 when we began coding Polkadot. Actually, there was no Substrate. It was all just in one repository, and everything was called Polkadot dash something. All of these, all the crates. Now, I had always sort of imagined that we were going to pull off the general bits of Polkadot so it could be used for other chains, with the eventual idea that let's hope it would be able to be used for the parachains as well. But that kind of finally sort of came to fruition in I don't know, about early to mid 2018 when we split the code bases up. And the Substrate repository. I think actually the Polkadot repository got renamed into the Substrate repository. If any sort of digital archaeologists can find that, and then we actually started the Polkadot repository afresh with it using the Substrate crates, and it sort of, as we demonstrated later on in that year when I sort of got on stage and did a blockchain with Substrate, it was the idea was to demonstrate that this could really be used very succinctly to create a fast, speedy blockchain, very, very fast, very easily, and with not a small amount of fun in doing it. And that included the UI because we had this really cool kind of metadata framework that allowed the UI to basically facilitated all of the interesting features that you're adding to your blockchain to be injected into the sort of JavaScript framework that you can use to create the UI. And it was at this point that it was clear that Substrate, that we were bringing to the world that, hey, look, Substrate is this general platform for blockchain development. Now, after that, it evolved with Polkadot. It got a lot of new features, partly those features that Polkadot needed, and partly features that we figured were pretty useful, even if Polkadot didn't really need them, still pretty useful for developing blockchains fast. And we eventually sort of, in the same year, in 2018, one of the things that I was working on sort of very much focused was Frame. This is the framework for runtimes, where runtimes are the business logic portion of the blockchain. So everything apart from the networking and database, none of that database RPC, CLI sort of stuff, but rather the internal business logic. And Frame is not simply modular. I mean, Rust is a modular language. Frame is beyond modular. It's modular, but it's also expressive for the kinds of concepts that you have when you're writing the sort of internal business logic of a blockchain. I'm going to go into that a little bit, but it really does, for anyone that's used it, it really does help speed up your ability to innovate and iterate on blockchain stuff, and that's basically because you've got these these modules, these palettes we call them, that allow you to put together all sorts of kind of different hooks, whether it's new events, new storage, new kinds of transactions, alterations to the transaction queue, and a whole bunch of other stuff, and then compose them so you can actually put together these palettes. And the final sort of chapter in the story of Substrate is Cumulus, or at least thus far is Cumulus. And Cumulus is this sort of is finishing off the circle where Substrate sort of started life as being the underlying libraries for creating the Polkadot relay chain, and with Cumulus, Substrate can then be used for these parachains that sit on top of the Polkadot relay chain. So it sits both below and on top. With the idea potentially being that this parachain could even be the first ever Substrate chain, Polkadot itself. So you end up with Polkadot self-hosting, which is quite an interesting and potentially groundbreaking potentiality. So that's the history. Let's talk a little bit about the goals. What is it that we're aiming for Substrate to do? So the first thing is obviously it's Polkadot's core, right? It's the thing that makes Polkadot work. It's what Polkadot's built on. So it has to be able to be good enough to power the Polkadot relay chain. That was its sort of first and foremost goal. The second is that it is a parachain platform. So not only do we want it to power the relay chain, we want it to be able to be used to create parachains swiftly, easily, joyfully, all the rest of it. And this means that Substrate has to be able, must use the WebAssembly sort of platform for its business logic, because the business logic is the bit that has to be checked by Polkadot. So Polkadot fundamentally requires its parachains to be validatable through the use of WebAssembly. So therefore, as a parachain platform, all of this business logic must be built down into WebAssembly. So for those, I sometimes get a question of, well, can't we just always have Substrate be kind of native? And this is why the answer is kind of no, because we do want Substrate to be a parachain platform, and if we allowed for Substrate to have runtimes, have the business logic that was always native, then it would preclude that. So the next thing is that it really must be developable. So it must be like very easy to develop stuff on it, and that's why we sort of brought in Frame. Frame's made so that you can very easily, very joyously, like it's nice to use, develop new business logic within Substrate. So these domain-specific facilities, as I mentioned earlier, storage, transaction types like dispatch types, transaction extensions, and we've even sort of introduced things like the ability to have new RPCs, off-chain workers, which I'll go into in a second. And you can really configure your blockchain to do all of this stuff very easily, but also all of this stuff is very modular and just sort of automatically fits together, and all of the sort of different modules that you bring together will be able to expose their functionalities across all of these dimensions out into the final blockchain that they've been composed into. It's fast as well. Like it's really quite good. We've done a bunch of optimization work, but our goal is to make it as fast as possible. And we've seen some pretty high transactions per second, given that we've been running on commodity hardware, and we've got a bunch of stuff that there's a bunch of reasons why it's fast, but it remains a key goal of Substrate to be performant, on top of the flexibility that we offer with Frame. Obviously, we want it to be safe and secure. And to this end, it's been audited. We've had a sort of a fairly large, comprehensive audit of the code base, and it's going through constant review. And basically, any alterations to it that are likely to be used or active in Polkadot, also have incremental audits, external audits by a security company as that code goes in. And in addition to this sort of auditing system, we also have Rust's type system, which is pretty extensive and can be used fairly nicely at times in order to give you compile time guarantees on certain relatively high level concepts. One of the examples of this would be the imbalance system in the in-frames currency, which essentially ensures that you don't accidentally burn or mint tokens when you don't mean to. And it sort of looks after that using a kind of Rust's slightly half-baked version of linear typing, and it sort of helps it uses the compiler to help guarantee that you're not accidentally creating or destroying stuff that you shouldn't be. And finally, it does, like, one of our big goals with Substrate is to ensure that it does what you need. Like, we built it to do what we needed, but you know, we also want this. You know, it's in our interest. We want people to build parachains, but we want this to do what you need. We want to provide the underlying functionality so that you can innovate. And you know, I find that the best way of doing this in general is to innovate ourselves and try and generalize the functionality that we need where possible, so that others you know, can use that. So the next little bit of this talk is I just want to go over what we've accomplished in the last 12 months. I spent a while going through basically every pull request into the Substrate repo. And obviously there's a lot of minor stuff in there, but I want to go over some of the bigger things that we've accomplished, that we've managed to land in the code base. So the first thing is probably something that many of you are already aware of, but if not, off-chain workers. So off-chain workers are relatively, I think, a unique feature. That said, there aren't that many blockchain frameworks out there, but a unique feature of Substrate that allows you to write code that operates off-chain, so that operates, you know, outside of the sort of consensus bound system, so that just operates on nodes in the network, but not necessarily every node, and certainly isn't required to synchronize the chain, but that will be able to use, like, as part of the environment the code runs in, all of the stuff that you expect to have on chain, so stuff like, you know, storage. But it can also do things that you can't do on chain because it's running off chain. So it can do things like make and send transactions. It can do things like go to the web. You can like look up some web page or JSON or whatever. And this is, you know, this is pretty groundbreaking for a few reasons. I mean, but basically it really does facilitate this, what is traditionally a very problematic need, which is that within the blockchain, you can't really do anything in the external environment. You have to have, like, kind of code running somewhere, oracleizing or actuating, and managing that kind of interaction between what's happening on chain and what you actually want to happen in the real world. And what this does is it allows you to write that code succinctly and in one place. So it's in the same place as where the rest of your blockchain code goes. And we've actually used this ourselves. There's a sort of heartbeat feature that ensures that validators kind of check in if they haven't, if you've got so many validators, there's no need for them to sort of check in by producing a block in a particular session, and they check in using this kind of heartbeat, this kind of, yeah, I'm really here, I'm online, and it actually uses the off-chain worker in order to send that if it thinks it's not going to produce a block. But obviously, the potential for this is huge. Any kind of oracleization or actuation can be done by it in principle. Next thing, big thing that we've been working on is benchmarks and weights. There's going to be a talk about this by Sean in I don't know, an hour or two. But basically, this is why Substrate can get away without having gas, right? This is why Substrate doesn't need this extremely slow, extremely expensive dynamic resource metering that is in Ethereum. The reason is that we basically pre-weigh, we pre-compute how much time, how much resource a given transaction is going to take. And we call this the transaction's weight. Like basically how heavy is it, how much effort is it going to be to execute. Now, in order to determine this weight, we could just pick a number out of the air, but that's obviously problematic if our number is too low. I mean, it's a bit problematic if it's too high, because it means you can't do as much or things are more expensive than they should be. But it's much more problematic if it's too low, because you end up with something similar to the Shanghai attacks on Ethereum in 2016, when someone can DOS the network basically by sending a lot of cheap, underpriced transactions. In order to determine the correct weights, we have a benchmarking system that actually goes off and tries to execute these transactions, generally using like a worst case parameterizations or circumstances. And we now have a fairly comprehensive system end-to-end for determining weights and ensuring that they stay up to date. And this is in sort of dramatic contrast to the equivalent in Ethereum, where you have gas prices for the various operations, which were kind of basically done once back in mid 2015 on mine and Jeff and Vitalik's laptops, and then haven't really changed very much in the years following, even though obviously hardware and software has improved a lot in that time. Well, we're not going to make the same mistake. So our benchmarks that we use to determine these weights actually run continuously and are continuously measuring how fast, how quick it is to do these transactions, and then putting those numbers, folding them back into the code base without any real need for human intervention. Another thing we've been working on that's been taking up one or two developers' time is optimization. So there was a bunch of low-hanging fruit that were able to make Substrate go a lot faster with relatively few changes. But to run through the optimizations, there's a new Parity database, which is quite dramatically faster than the previous RocksDB. Still sort of experimental, but you can use it on anything that isn't production, and you'll see that the times are sort of block import times, sync times are going to be a lot faster. There's now in use, I mean, this is kind of old, it's about 11 months ago, but we've folded in the JIT compiler for WASM. I mean, it's kind of sort of only really kind of somewhere between JIT and ahead of time, in that you do pre-compile it before, like it's not literally just in time, but I'm calling it JIT because it doesn't get compiled when everything else gets compiled, but at some point later. Then there's storage IO has been particularly things like the append item. So you can now append an item onto a vec of things, and it goes fast. It doesn't have to decode the entire vec of things in a storage item and then put something on the end and then re-encode it and put it back into storage. Instead, it actually just basically nudges the length along one and sticks it on the end, which is how it should be. Transaction queue has been optimized and improved, as is the block builder. We do epoch pruning in order to make sure that the underlying consensus system doesn't get problematically slow if there's a large unfinalized head. We've got the ancestry cache also that speeds up, and synchronization has been optimized as well. There's also some stuff to do with how the messages are handled in consensus that has been optimized. So a lot of stuff, a lot of it behind the scenes, but rest assured that it is one of our focuses, and we have been doing work on it. The palette library has been built up over the past 12 months. There's now over 40 palettes just in the standard library, and then if you go outside of the Substrate code base to like Polkadot or the ORML or wherever else, there's obviously a lot more, and across the business logic spectrum. So governance, obviously quite a lot of work has been done, but wallet management as well. I'll go into that in a second. We now have some pretty impressive level of Ethereum compatibility thanks to Project Frontier. Bit of a questionable name, that, given that the original release of Ethereum was called Frontier. It's nothing to do with that Frontier, it's just another frontier. But basically, we can now have full EVM compatibility, so you can deploy smart contracts that work on Ethereum actually directly into Substrate using this special EVM palette. And quite impressively, the RPC, so the Web3.js, the thing that Web3.js talks to, is also compatible. So basically it works with all of the stuff, that the off-chain stuff that uses Ethereum. One of the really kind of, from my point of view, cool things to sort of demonstrate about Frame that there has been a bit of work done on is the account management and how account IDs are used to identify and authenticate transactions, basically. Originally, these two concepts were the same. So authorization was the same as identification. What I mean by this is basically you have an account and you have the account has a public key that identifies it. And the only way that you can use that account, the only way that you can authorize, let's say, a transfer from it, would be to use the private key, the secret key, to sign a transaction. And there was no absolute necessity for this. It was just the obvious and easy thing to do. It's similar to basically every other blockchain. But now that we've added a few other things, like for example the proxy palette, we can decouple these two things, and we still use the public or a public key or something that looks like a public key, a 32-byte identifier, to identify an account, but we don't need to use the coupled private key in order to authorize anything from that account. Indeed, there is a type of proxy now. It's called anonymous proxy. It really shouldn't be called anonymous proxy. I just couldn't think of anything else at the time, but in retrospect, I should have called it a pure proxy. And what it is, it's basically like a secret key, or a public key, but one that doesn't have an according secret key. A little bit like smart contract addresses on Ethereum. It's just a hash, but it comes with another. When you build it, it's like, well, how do I authenticate with it? Well, you actually get initialized with a proxy, so with another account's public key that basically allows that other account to do anything from the new account, from the point of view of the new account. So you can basically authorize this other account to act on behalf of this new account. And the cool thing with proxies are that you can add other accounts that can also authorize, and you don't even have to. They're quite eminently configurable. So you can have many of these accounts. You can just have one account if you want. You can delete. You can add, remove them. You can attach specific requirements of what kinds of transactions they're allowed to authenticate, whether it's governance or transfers or staking or whatever. And you can now introduce time delays to them, so that basically one of these can be require a day's time delay before it's actually allowed to enact a particular transaction. So it has to sort of pre-announce what it's going to do. And that pre-announcement time, that period, can be used in order to cancel the transaction from one of the other proxy accounts. There are a few others. There's derivative accounts. There's this social recovery that sort of utilizes it in a similar way. There's a multi-sig, which again is another type of account that doesn't have a secret key pair for its account identifier. So we're now at the point where account IDs are actually just general 32-byte identifiers, and there's no necessity for them to be public keys at all, or at least a public key that has a secret key, known secret key on the other side of it. Scheduling is a nice little one, which you can, once sort of considered a bit of a holy grail of Ethereum of blockchain, you can now schedule something to happen in the future. And it works really nicely with the weight system, so you don't accidentally schedule too many things in one block. You can configure it nicely. There's priorities, there's all sorts of stuff. We have customized RPCs, great little feature. This basically allows your palettes, your runtime modules to expose sort of natural RPCs that the node will eventually sort of expose to the users of the node, that allow your palette to be interacted with in a way that, in a sort of rich way over a JSON RPC. Transactional storage, again, one of the sort of things that people were really sort of found maybe a little hard to handle, was this idea of validate then modify within your transactions. So your transactions had to first check their inputs, and then only after the inputs are known good, once you're definitely not going to bail out, then modify anything in storage. Sometimes it was difficult to do it in this way, yeah, now you don't have to, because we have the ability to revert storage changes. Offline MPOS, one that came in and is constantly being sort of updated, but basically this allows high quality solutions without stalling the chain, as is the case if you do all of the stuff on chain. And we've got a lot more diagnostics and metering, using basically a Prometheus, turning the node into a Prometheus endpoint. We have prefix storage items, allowing you to iterate over all storage items in a map very efficiently. And one of the big ones, the core libraries of Substrate and the frame libraries are now Apache 2, which basically means you can distribute your modified runtime without having to necessarily open up all of your code. So very quickly, what are we working on? What's about to land? Well, we've got runtime worker threads. So basically introducing parallelism into your runtime. Pretty big one. This is still something that's being worked on, but there is a pull request open for the underlying technology, which is pretty awesome. XCM is something that we're working on for the ability to send and receive messages between chains, but in particular to allow it to the send and receive engine to be integrated well into palettes that provide the kind of services that you want messages to act upon. For example, if you're sending balances, you're transferring some tokens across, then it's got to really be able to be integrated easily into your balances palette or your assets palette or whatever other palettes that you have to handle tokens. We have a very exciting one here, Frame v2. So, learning these macros, these fairly sort of arcane kind of APIs syntax is always a big stumbling block for people that are starting out on Substrate. We have a new version of Frame now. Again, pull request is open, should land reasonably quickly. That turns everything much more into idiomatic Rust. It feels much more natural. It's basically all done through procedural macros, nice little sort of tags that you put before your things, your event and your configuration trait and so forth. Much more expressive, much easier to learn. Yeah, better balances, something that I'm working on at the moment. This is essentially to facilitate exotic chains where you've got a lot of different assets, and none of them are special. You don't want to force an account that holds these assets to necessarily hold some other master asset. And this will facilitate that. And there's a lot more stuff coming. Asynchronous smart contracts using the actor model, something that we're working on now. Local storage for off-chain workers. Palette versioning and migration, just to really make that stuff that story a lot better. Pre-compiles for EVM to make that faster, and a new consensus algorithm, Sassafras. That's all, and I think I'm bang on 30 minutes.
Yes, you are. Thank you so much, Gavin. That was great. Unfortunately, we have no time for questions. Gavin, do you have time to join the Discord to maybe answer some questions from folks?
I will do, yeah.
Great. Okay, then move over into the Discord. This channel session is, you can see like from the Discord a keynote from Gavin if you want to ask him some questions and get some more information from him. Next up, we have Fred. So we're going to end this session and move into there. Thanks again, Gavin.
Cheers. Ciao, ciao.